All right, here we go. Determinants. All right, determinants is kind of like a property of a matrix. Okay, it's a number that a determinant occurs with, and determinants can only be done for square matrices. So if you're a square matrix, that means like a 2 by 2, 3 by 3, 4 by 4 even. It has to have the same number of rows and columns. Go and put your phone. Talk all the way to desk. It's too tempting. You're sitting there texting. All right. So has to be a square matrix. If it's not a square matrix, you can't find the determinant of it, and it would be called undefined. Okay. So if I give you a non-square matrix, it's undefined. So I'm going to show you how to find the determinant of a 2 by 2. It can be done by hand very easily. Anything bigger than a 2 by 2 it's a lot of calculations. It's kind of like the multiplication of matrices. It's a lot of calculations if you get bigger than 2 by 2s, or the bigger the matrix you have, the more calculations it's involved. So define the determinant of a 2 by 2. A, B, we'll call it C. A, B, C, and D are the elements in there. The way that works is you multiply diagonals. A times D minus B times C. 2 by 2s, I generally do by hand. I don't type them into the calculator just because I can do multiplication fairly easily with that. So top left times bottom right minus top right times bottom left. Yes, always will be a minus. Now the signs of these numbers may change that to subtracting a negative, which is plus, but it's always a minus when you set it up. Okay. Look at an example that's an actual numbers example. Notice that I'm not putting the brackets. I'm putting straight up and down bars. Straight up and down bars means determinant. Looks like the absolute value symbols. Okay, so they're determinants when they do that. So let's find the determinant of 5, 4, 3, 1. I don't know. Diagonals, multiply 5 times 1 minus 4 times 3. 5 minus 12, negative 7, right? Okay. 2 by 2s. Do that way. Let's do another 2 by 2. Another way that you might see determinant listed is the abbreviation DET. And that's going to be familiar when we go to do this with a calculator for a bigger one. That's the abbreviation they're going to use. But I've seen it on ACT problems where they didn't put it in bars like that. They said DET, and then they wrote a matrix inside of that. So maybe something like negative 6, 8, negative 4, and negative 5. So they may present it in that way. So if you see the absolute value looking bars, that means determinant. If you see DET and then a matrix, that means the determinant of that matrix. So this is a 2 by 2 again. So I'm going to multiply negative 6 times negative 5 minus 8 times negative 4. It doesn't matter what order you write that in. Yeah, negative 4 times 8 or 8 times negative 4. That's going to be 30 plus 32. Negative times negative is positive. A minus negative 32. Double negative. Plus plus. That's always been the case. So positive 62. Now, let's look at doing that with the calculator just so we know how. Okay, so with the calculator,
Are you going to record it?
yeah, I am recording it.
Oh.
Just a little bit different than what I've been doing, trying to do a new thing. It's a little more cloud-based. So just something different for us. All right, so we need to put the matrix in there. So let's just use matrix B that we just did on example B and write that one in there. So second, over to edit. And we're doing a 2 by 2. And then put that matrix in there. And I've already forgotten what it was. -6, 8, -4, -5. -6, 8, -4, -5. Okay. So you put that in there, and then we want to do something with it. So it's in the same place as you went to find RREF. You're going to press. You're going to go back to the home screen. So second mode to get back to the home screen, and then go to matrix. The first one is DET. And then you pick put the matrix that you put that in there. And you can, I can't do that. And then 60, I almost hit enter and I couldn't do it. 62. So what size matrices can we do this with? Squares. On 2 by 2s, 3 by 3s, 4 by 4s, 20 by 20s. Yeah, it's got to be that size. No. If they ask you to find a determinant, it's going to be a square matrix. If they do give you one that's not square, then you know it's undefined. No.
May I have your attention, please? There's a white Nissan blocking the band entrance. It needs to be moved.
All right.
A white Nissan blocking the band entrance to the practice field needs to be moved. Thanks.
All right. So let's do a 3 by 3 just so we can make sure we feel okay with that, because the application uses a 3 by 3 that I want to use. So I'm going to use bars there. The determinant of that particular matrix. 2, -1, -3, 4, 1, 0, 3, -4, -2. You're not going to do 3 by 3s by hand. I can show you how if you want to know, and just see me like after you get done with your quiz. I'll be glad to show you how to do it by hand. There's a couple of different ways to do that. It involves breaking that thing down into a bunch of 2 by 2 matrices and working it from there. So it's pretty neat, but for all intents and purposes, in any non-engineering math, I don't think you're going to have to do that by hand. Only time you would have to do it by hand in an engineering sense is if you had a variable inside of that matrix that you need to figure out for. And some of you may be headed that way, so I'll be glad to show you. So I'm going to put that matrix into the calculator. Over to edit. 3 by 3. 2, -1, 3, and 4, 1, 0, 3, -4, -2, and then I'm going to use. I've already used that command. I'm just going to use it again. Arrow up and copy it, and you get what y'all say. 45. Is that what that number is? 45.
Yeah.
Okay. So determinant of a 3 by 3. You're definitely doing that with the calculator. I don't mind you doing the 2 by 2s with the calculator, but it's just 2 operations. So I'd say, you could do that by hand. It'd probably be quicker to do it by hand with the 2 by 2. All right. So determinant of a matrix. Let's apply it to something. So where can this be useful? Surveying is one area where this could be useful. That it's really useful now with the GPS tracking abilities. You already seen the farms now where they got the little up on top of the tractor, that's a GPS locator, like satellite guided tractors is what I call it. But yeah, and it'll plow the field with nobody sitting in it. It's amazing. But the area is something you might want to know, and with those coordinates, you can figure out the area of that using a matrix. Okay, so area of a triangle. Well, a square is actually two triangles, and any polygon shape can be cut up into triangles, and so triangles is what you want to kind of use. The reason you want to use triangles in surveying, cosine, like those kind of things, and that works with triangles is what it works with. So that's why the application with a triangle is useful. So well, that's what I'm saying is you got to chop it into triangles, and they find the angle, and it depends on it makes the coordinates there. But with the GPS stuff that's available now, it's amazing what they can do. All right, so area of a triangle. What's the formula if you know everything about the triangle? 1/2 base times height. Okay, that's what the area of a triangle is. So with a matrix, have is 1/2 times the determinant of the vertices. It's not. It's not. This is not going to, because it's not on your test. No. All right. Notice I put the last column is all ones. That has to be there. It will always be all ones. Now, those X1, Y1s, X2s, Y2, X2, X3, Y3, those are the three corners of your triangle. That's their location on a coordinate plane. All right, so let's say we had some grid drawn, and we had 3 points. I'll give you the ordered pairs for those points. So this ordered pair, let's say it's 2, 5. This one is 3, 15. No, you're not going to have to graph. It'll be already drawn for you and given to you. Okay, and then this last one, it's like 10, 10, 8, something like that. I mean, it seems reasonable. That's where they're located. All right, so what you would do to find that area is plug in those points. And it does not matter which one you pick, the X1, X2, or X3. Just start with one of them and go around the triangle. It doesn't matter which one. So if I start with 315 and then go 2, 5 and then 10, 8, and that last column is always going to be ones. What do we know about area? It will always be what kind of number? Positive, yeah, and it's the square units. That's also true, that whatever units we're dealing with is going to be square units. Okay, so it's going to be a positive number and square units. We know that because it's area. Okay, so when we find that determinant, calculator there. So I'm going to go to the matrix and enter in this matrix so I can find the determinant. So I got 3, 15, 1, 2, 5, 1, 10, 8, 1. Okay. Quit. I'm going to go ahead and find that determinant, and then I got to remember to multiply it by 1/2 when I get done with that. So that is 77. Okay, that's what I was hoping somebody put your ordered pairs in a different order. Like you didn't. I put them in 3, 15, like this order. If you swapped one of them, it can change the sign of your answer, but you got the same number, right? Yeah, but it's always gonna be negative. Right? But it's always, area is always what kind of number? Positive. Area is always positive. So you just know when I get that determinant, if it's a negative number, Well, it's supposed to be positive because it's area. Okay, that's what you got to know. And depending on what order you put your coordinates in, what sign it'll change. Like if you swap two of these, that's one of the neat properties of matrices. From it's a little deeper understanding. Right, which we're going to calculate it to a decimal. 77, half of 77.
So you want a decimal on it?
Yeah, I'll take a decimal on this one. 38 and a half. 38 and a half. Let's say it's in square feet. Or you write feet squared or 38.5 square feet. Those abbreviations are synonymous with things. Use miles if you're talking about a large area, like the state of California or something like that. If you're talking about a field or something, what unit do we do? The acres in that, and what's an acre? It's a calculation based on feet. So you get it in feet squared and divide by 263 square feet an acre, something like that. I can't remember those numbers right off the top of my head, but they're there. Okay, so there's an application of using a determinant. There are other applications in kind of deeper level math for high school purposes. That's what you could use a determinant for. Nothing else really to it other than that. You can do it with the calculator. You go bigger than that. It's just got to be square. Okay. All right. Let me.